Hey everyone! So we are doing spheres today. And you guys, by the way, sometimes you'll hear me say spheres. I can never say it same way twice. So yeah, I know it's because I'm not from Texas, but I kind of sound like I'm from Texas. All right, so guys, when we're doing spheres today, we're going to talk about both surface area and volume. Remember, surface area is everything that's on the surface. Volume is everything that's on the inside. So let's go take a look at our formulas. Right here, surface area. Okay, remember, R is the radius. Now, that talks about the radius of the base when we're talking about surface area. Okay, well, wait a minute. Do we have a base when we talk about spheres? If we are dealing with hemispheres, then yes, we do. Otherwise, guys, the other thing to think about this is that this is the radius of the great circle. Okay, and let me erase this and make it to where it's a little bit better. Okay, the radius of the great circle. Okay, and remember, I talked about that in our vocab video. Okay, all right, so surface area right here, 4 pi r squared. Now volume is a little bit different, 4/3 pi r cubed. Now, I'm going to rewrite this, okay, so you guys can see it's also 4/3, okay, pi r cubed. You will also see it written that way. Okay, r cubed. Hey, guys, when we do this in our calculators, I'm going to show you how to do this in your calculators here in just a second, okay? All right, so let me help you guys, though. I want to do a problem with you guys on the algebra review. I'm going to do letter A with you guys right here. Okay, so right here, if you guys notice, and I'm going to highlight it, there's an r cubed right there, isn't it? That's what we are trying to find. Okay, we're trying to find r. So we need to work backwards. Okay, so I'm going to rewrite this. Okay, we got one up. Let me rewrite it the correct way. There we go. 113 equals, and then I have 4/3. Now I'm going to put that in parentheses. Okay, pi r cubed. Okay, so guys, right here, when I look at this, okay, I can work this out a couple different ways, but I want to get r all by itself. Well, I want to get rid of that 3, but I need to get rid of the 4 pi. Well, let's think about this. Okay, the opposite of, this is division. We're dividing by 3. So the opposite of dividing by 3 is multiplying both sides by 3. These 3's cancel out, don't they? Okay, all right, so you have 113 times 3. Let me do that in my handy dandy calculator. 113 times 3. So this ends up being 339 equals, and then we're left with 4 pi r cubed. Okay, that's what we're left with. Now, if you guys remember, okay, when we divide and we want to get r all by itself, well, I could divide by 4 pi, but I need to put it in parentheses, don't I? Okay, divide through by 4 pi. These guys cancel out, don't they? Okay. All right. So I have 339 divided by, and then in parentheses, excuse me, 339 divided by, let me get this right, in parentheses, 4 pi. Now that gives me, I don't know what you guys, but I got 26.9, what is it, 7? Okay, equals r cubed. Okay. Hey guys, if this was r squared, we would just take the square root of both sides. But this is r cubed. So what we need to do is take the cubed root of both sides. Okay, so let me pull up the calculator here. I want you guys to notice what I do. I put in, okay, and I'm going to hit math. And then if you guys notice, when you hit the math button, you can go down and there's a cubed function and there's also a cubed root function. Okay, do you guys see? And so what we would end up doing is we would take the cubed root of 26.97 and that would equal r. Okay, so when I take the cubed root, 26.97 equals r, it gives me 3.0. Okay, so 3. So r equals 3 is what we would round this to. Okay, so again, your cubed and your cubed root functions are underneath the math button on your calculator. Okay. All right. So that's just kind of, helping you guys get that started. But now let's get into the meat and potato of spheres. Meat and potatoes. Ooh, that actually sounds good. I may have to make that later. Okay, let's go down and take a look at number 4, you guys. I'll meet you down at number 4. All right, you guys, down here on 2 through 5, it says that we're going to find the surface area of the sphere. Okay, now remember, we're going to show all of our work. We're going to include the formulas. We're going to round to the nearest tenth. But guys, if you see in number 4 right here, it wants the surface area of a hemisphere. Okay, guys, if you look on your formula chart, there is not a formula for the surface area of a hemisphere. Okay, so let's think logically about this. If we found the surface area of the entire sphere and then we cut it in half, okay, maybe we can start there. Okay, so let's find the surface area of the entire sphere. Okay, surface area. Hey guys, what formula should we use? Yeah, the formula for surface area of a sphere, 4 pi r squared. Okay, so we're going to plug in. We don't know the surface area. We know 4 pi is pi, right? And then it tells us the radius. Well, hey guys, the radius, it gives it to us, is 8 meters. Okay, so we plug that in our calculators. And when we plug that in our calculators, we get 804.24. Okay, now remember, this is for the full sphere. Okay, that is for the whole thing. Okay, I'm going to pop up here for just a second. The surface area is everything on the outside, the area of everything on the outside. But if we want a hemisphere, okay, now we've got this part on the outside, but when we cut it in half, now we also have this on the outside. Okay, so if I take the surface area of a sphere, I cut it in half, that'll give me this curved area, but we need to add in also the area of a circle, okay? And this is the great circle. Remember, it goes through the center of the circle. Okay, so what does that look like? Here's what this looks like. Okay, so we said we want half of the whole sphere. So for the surface area, and I'm going to put an H right here for the hemisphere, we would take 804.24 and divide it by 2. But then we said we were going to add in, okay, the area of the circle. So we need to add in a pi r squared. Okay, we need to do that because of that great circle on the bottom of the hemisphere. That great circle is this part right here, isn't it? Okay, that now is on the surface. Okay, so I want you guys to tell me, you work this out, plug in all of your magical numbers, and tell me, including your units, what do you get for the surface area of this hemisphere? How'd you guys do? Okay, so when we plug in, okay, the area of the circle, well, guys, that great circle, right? That great circle has the same radius. So it would be pi 8 squared. Okay, you add that to half of the surface area of the sphere, you get 603.2 meters squared. Hopefully you remembered to square it because we're talking about surface area. Okay, now I'm going to let you guys do number 5 on your own. Let's go down and, hey guys, I want to do number 9 with you. Go down to number 9. Okay, now on numbers 8 and 9, it says that we're going to find the volume of the sphere, but it gives us the surface area. Okay, now, guys, I want you to think about what I've said all these times before. If it gives you the surface area, you're going to start with that equation. Okay, so I want to start with the surface area of a sphere is 4 pi r squared. I'm going to plug in what we know. Okay, we know the surface area. The surface area, it gives it to us right here, doesn't it? Okay, I plug that in. 36 pi equals 4 pi r squared. Now notice I kind of give you guys a hint here. You're going to find the radius first, because once we find the radius, then we can find the volume of the sphere. Okay, hey guys, practice it. I've set it up for you. Can you guys tell me, what do you get for the measurement of the radius? Did you guys remember that a radius is in linear units? Okay, you should have gotten 3 centimeters. Okay, now that we know the radius of this particular sphere, okay, or we could even say, hey, why don't we say this is the radius of a planet, right? Can you guys imagine how small that little planet would be? Okay, so now we can find the volume. We can find how much fits inside that sphere. Okay, so can you guys tell me which one of these formulas should we use for volume of the sphere? Okay, did you look at your formula chart and or the notes and say that volume equals 4/3 pi r cubed? Okay, so now we got to look. We don't know the volume. That's what we're looking for. So volume equals, okay, 4/3. Remember how I talked about putting 4/3 in parentheses at the beginning of this video? Okay, 4/3 pi r. Well, guys, don't we know the radius? Yeah, we know that the radius is 3. We just found it right there. Okay, so that would be 3 cubed. Okay, in your calculators, guys, remember just a second ago, I showed you guys earlier in the video how to get to the cubed. So how do you cube something in your calculator? Okay, all right, now, guys, I want you to look at how I set this up. 4/3 is in parentheses. Go find the volume, okay, of this particular sphere and tell me, what do you get? All right, how'd you guys do? Okay, remember, you can put this in your calculator just like that if you put the 4/3 in parentheses. Okay, did you remember to cube something? You hit the math button and you can go to cubed. Okay, now during class, you might want to ask your teacher to show you another way that you can do something cubed, okay, raised to the 3rd power. Okay, so ladies and gents, spheres, okay, most of you guys will really like spheres. The main thing you need to remember is the proper formula and whether or not you square something or you cube something. Okay, you guys know the drill. We'll see you in class. Adios.